In this question, we want to show that the 4 points A, B, C, and D all lie on the same plane. Our strategy is going to be to determine the equation of the plane that contains A, B, and C, three non-collinear points. And we'll do that by determining vector AB and vector AC. We'll cross those two vectors to get a normal of this plane, and then we'll sub in the coordinates of one of these points to determine the value for D in that plane. What we'll then do is determine whether or not this point, D, lies on that plane. So, the vector AB is equal to negative 5, 50, 40, and the vector AC is equal to negative 35, negative 4, 44. We're going to cross these two vectors to determine a normal for our vector, to determine a normal for our plane. Now what we're going to do is we're going to use, instead of negative 5, 50, 40, we're going to use 1, negative 10, negative 8. We're going to multiply this through by negative 1/5, and we can do that because we're looking for a normal vector, and by doing this approach we're going to keep our numbers a little bit simpler, and we're going to just reduce the values in the normal vector that we get. So, crossing 1, negative 10, negative 8 with negative 35, negative 4, 44 gives us the vector negative 472, 236, negative 354. So the normal vector in question is this. Now, we can actually, believe it or not, multiply this normal vector through by negative 1 over 118 and reduce it to 4, negative 2, 3. So actually our normal vector is actually 4, negative 2, 3. What we can then do is sub in 5, 10, negative 40 to 4x minus 2y plus 3z plus d equals 0, solve for d and get 120. So the plane that contains the 3 points A, B, and C is 4x minus 2y plus 3z plus 120 equals 0. All we have to do now is test D. See if D lies on that same plane as well. Well, plugging in negative 15 for x, 15 for y, and negative 10 for z leads to a true statement, so all 4 points must lie on one plane.